Hi everyone. Do you feel good today? I hope you're having fun on this conference as I am. So I'm one of those examples from this morning when Art was mentioning that if you visit one-year conference as an attendee and you like it, then you can challenge yourself with suggesting a talk, which is something I actually did because I liked the conference very much last year. So here I am. But before I continue with my topic, let me give you a little introduction. As mentioned, my name is Irja Straus. I'm coming from Croatia, and I work currently in a company called Gideon. Gideon is a robotics company. More about this context a bit later. I have 14 years experience in various roles. So, for example, I was a tester, obtained many roles in testing. I was also working as a business analyst, product manager, but within all of these roles, I always found something useful, which I can use in my next adventure. So I sometimes like to say that I'm a continuous explorer. So why I'm here today in this talk, we will go over about a few different things, such as what's my context and what's the value of testing in this particular context. We heard about it already a lot during the day. Also, we will go over some different techniques we apply on different parts of our product, like hardware, software. And also, I will also try to share with you where do we put automation in place in this whole story. And last but not the least, along the way, I will share some, well, not scary stories, but real life situations we had during our development and testing. So let's start with a little bit of context. So as you can see, and as I mentioned before, I work for Gideon, which is a robotics company. So what we do, we basically do autonomous forklifts that operate in the different types of warehouses. They work together with people along the way. And we basically do loading and unloading of trucks. Like we pick up the pallet and put it in the trailer. I mean, not us, but this robot does that. So what's the problem? The main problem we are having here, it's this interaction with the people. So you have a person, a human being, and you have a 4.5-ton vehicle which moves autonomously with its own decision-making and etc. So I consider this context as a high-risk context. But the good news is that in this high-risk context, we basically provide a lot of value with testing. So as I was talking this morning to my friend, and before we worked in the same company, and she said one thing, I'm very happy that I don't have to explain or advocate for my own value or why do they need me in the company. And this is it. This is exactly what I'm currently experiencing in this particular context of mine working with such a product. Because our role as testers is to emphasize the risk, but not only to emphasize the risk, it's also to plan some preventive measure for those risks and explore around them. Our role, as we heard already today during the keynote, it's not about breaking stuff, breaking things. So in my context, especially that would be weird because, breaking piece of equipment like lasers are very expensive, or cameras, which you can find on this product. Well, that wouldn't be so smart. especially if you're a startup, and you know, startup life doesn't go well with like endless amounts of money. So I have to be mindful with what I'm doing, and I have to be mindful about like different testing approaches I will apply on testing software, but also testing hardware. So to continue with this story, I want to why I picked this topic anyway. Like what I want to do here. Like I picked this topic because when I joined this company, I always considered that like testing hardware would be something that's pretty much straightforward. Like maybe I won't be able to use a lot of my skills I obtained before. Maybe I will not be able to be so much like creative. But my experience so far actually has proven me that this is just partially right. So let's see why there is also like a lot of room for creativity and exploration when you're testing hardware. So I won't like go in too many details of this, but if we look at the hardware components we are having in our company, we can just split them into two main groups. First group are components we are buying from third-party vendors because we are not producing everything by ourselves. Second type of the components are in-house built components and solutions. First type of components is something we approach more with like let me explain it just. Those components are something we are like buying. Like we already know the quality, like what it has to be, what are the quality characteristics that we want to do. So what we try to do is like create different types of like toolkits or devices which we will use to inspect the quality of the things we bought. So we will perform, let's call it quality control, different quality control methods, and basically, like you can look at it as like checklist testing. Like I really like checklists too, as somebody already mentioned during this day. So this is like a great area to see that. But story behind testing our in-house solution is a completely different approach. So we need to adapt, as we heard so many times today. So this is a great area when I was like, yes, this is the time I can kind of brush my skills. I gathered a lot when testing software and dealing with this type of the products because I can explore. So this is like perfect candidates for exploratory testing. Before I move on a little bit further, why I think so, let's just align quickly what we mean by exploratory testing, just for the sake of this presentation. What I mean by it in this case is like continuous learning and test design and executions, but within the same session. This means basically that we will not be overly prepared and kind of script everything what we want to do with our testing, but we need to find just enough of the balance. Why I think that it's why I think so is one actually story I learned from my teammates. So let's take a look at this picture, and I will explain what this is. So first day I joined the company, and of course my teammates took me around and gave me a tour of our test facility. And walking around the test facility, I found this beautiful piece of wood on one of the robots. So I asked them, hey, what do we use this for? And then I heard an amazing story. Like, this is the tool, like this is our testing tool, which we have to use to unblock our testing. This is our workaround in testing, which we have to use to unblock and move on with our test. It's kind of a reset button. Hence the name čistač grešaka 3000, also known as bug cleaner 3000. Because what happens? Now I will tell you what was the root cause of the problem. So we made a hardware design for our robot and we placed the reset button on one place. And when the robot entered its, let's call it a station, well, the station wasn't very well designed, so you couldn't just reset the button. You couldn't just reach out the reset button in a safe way without, I don't know, hurting yourself, or it was even more impossible. Hence, this creative tool actually was very much needed just to unblock ourselves. Because, of course, when the robot reached out the station, there was another bug, which it took a bit, software bug, which it took some time to fix, but we needed to kind of continue our work. So why I'm telling you all of this, like when I heard this story from my team members, first I was like, wow, cool. This is a total new set of tools I will be having in this company, like Selenium, Playwright. Nah, it won't fix this problem. Like just a piece of wood. And then I asked, then I figured, wow, yeah, like we did it, like we did our own hardware design. And we didn't just test this prototype or the idea enough at the time. We just didn't see it as, like, we didn't see the whole picture. We didn't explore. And this happened. So what I realized is that even I had some prejudice when I joined, like, started to deal with hardware. This is gone. Like, I noticed that like immediately that we need to do a lot more exploratory testing on our hardware components to explore not only the claims, requirements, like reset button worked, but also explore all of the risks around it. So that was it. Moving on from hardware now to software. Software and the specifics of testing the robotics software is something that was bit more familiar with what I have experienced before in my career. But like there are also some specifics when it comes to that. So how we approach it, I know there are like a lot more layers or names or types of testing, but let's just put it in two major groups. So we have like unit and integration level tests. That's good. I will not say if we do it or not. Like we do, but not all the teams, you know, sometimes there are some shortcuts, which I don't recommend, but yes, this is what it is. So there are unit and level unit and integration level tests, and those are pretty much, I wouldn't say it's kind of much more different if you are, I don't know, working in robotics or in some other area. What is a bit more different is how we approach testing the software, but like this whole system, like system level tests. So this is how we call it. It's basically like product level tests. We are taking the whole product together, assembled, and test it in two different ways. We can use either simulation, like tools, or we can test it on the real vehicle. So let's dig deeper a bit more about on simulation, and later on we will see how it looks like to test the real vehicle. So first of all, what is simulation? I'm not sure if you're familiar with it or not. I wasn't. It was something new for me. And basically, when I saw when I saw it for the first time, immediately I imagined, but this is just like Sims. I don't know, I guess a lot of us played Sims in our lives, or you're familiar with it. It's basically a game where you create your own character, you kind of build a house for it, you can even model how it interacts with other characters in the game. Like, pretty cool. So, simulator, it's the same thing. Like, it just doesn't look that nice. I mean, showing on my laptop instead of here. So just graphics, it's a bit in our simulation, not that detailed, but it works for us. So for us, simulator is like the main thing we are doing, like the main tool we are using. We can look at it as a bread and butter of robotics testing. Simulator is basically a digital 3D tool, which it simulates the populations of like one or more robots and puts them into different complex, realistic environments. And from there you can build your own like worlds, also build your own models. These are like two main components of the simulator, like world files and models. World files are basically like these things, like all of the environments where robot is going, so like all of the elements. And models are things that are going around, like our robots, pellets, and other types of objects we can find in a realistic, in the warehouse, either testing warehouse we are having or the customer site. So when it comes to this tool, well, it doesn't come out of the box. We use Gazebo. Gazebo is an open source platform, but we have to develop it by ourselves. So in parallel to developing our product features, well, we have to develop one more thing, simulator, which is which is equally important as having a good working product. Having a good working tool is like even more important in some cases. So what do we have to pay attention to as testers when dealing with our simulation is testability. Like testability here is the king. What do I mean by testability? I mean that we have to have a fast tool. This is the first thing, like we have to achieve this higher real-time factor. Real-time factor is basically a measurement that will tell you if your simulation and robots are slower or faster than what you will see in the real life, in the real warehouse. Also, that it's also good not to have like flying objects all around the warehouse, so we need to build good models, like have realistic dynamics, so this pallet is here and not flying around. And when we are when we achieve those two goals, we can talk about like what we can do, test within the simulator, and what we cannot test within the simulator. Like knowing the limitations of our tool is practically is really important, because sometimes you have to distinguish, is it a bug within the simulation or actually we have a problem with our robot's behavior, like something is wrong. So that's one thing why testability really matters and why it takes a bit time to kind of gather some experience to distinguish these things. So, but moving on, like what do we test there, what we cannot test within the simulation? What we do mostly within the simulation, and we can test pretty much like confidently, are basic maneuvers. What I mean by that? I mean, like, does the robot navigate from the point A to point B in a way that it can kind of fit, turn around, pick up the pallet or not? So like basic stuff. Like we can think of it like sanity checking. Another thing we want to test thoroughly in the simulation is how robot completes the tasks we are assigning to. So each robot gets a task. It has to move from one point to another. So we can test that pretty much thoroughly in simulation, which is great. because simulator is almost always available. Well, of course, if you pay for the instances to Amazon or whatever, wherever you're having it. But I noticed that we have a like bonus use case, what we are also doing within the simulation. This is like not testing our product, but testing something else. Whenever we are going like to talk to some customer, we have to see if our product, I mentioned it's huge, it's 4.5 tons. Later you will see one picture where I stand, so you will get the comparison. So we need to see if the business case for this customer will be even like viable. So we also do that within our team. We perform analysis if we can even like take a look at this new customer or environment to see how our robot will perform there or not. I consider that a really nice benefit and a really like bonus other than testing the features itself. Moving on, what we kind of cannot test confidently or thoroughly are few really, really important things, such as like safety functions. Like I cannot just rely that all of the safety functions are in place by only testing within simulation. That wouldn't be so smart. Also, we cannot test semantics. Semantics is how well our camera and all of the models in behind will recognize particular objects within the space. It's very hard to simulate that deeply. You can simulate like basic check, but we need to kind of take more time on the robot to test those things. And physics. When I say physics, I mentioned flying pellets, stuff like that. That happens in the simulator, but there is no feeling of the space, of some movements you have inside the real facility. So those are some limitations we are having with our simulation. So since I already mentioned the robot, let's take a look like what does it mean to test the real beast? Like, how do we do it and how do we approach this thing? So I mentioned it's pretty big. So this big thing is kind of, something I haven't encountered before in my software life, let's call it like that. So like testing this kind of a product was pretty new for me and nothing similar to things I did before. So to be honest, for the first time, when I entered the test environment where we had one of the 2 test robots we are having in-house, I was kind of intimidated and like I was afraid to admit, but I didn't want to go close to it. Like I noticed that my team is like very like they're confident, they know what they are doing. And I was like just going around. And so I was pretty much intimidated to come even close to it. Wow. Yeah, that was really, really scary experience. So it's kind of different because I don't sit at my desk, at my computer to test the product. I have to get up, I have to enter the warehouse, I have to walk, I have to be mindful of this thing, and I cannot just sleep at my desk. So that was pretty much something like different because it basically puts you as a tester in a position that you are the part of the test environment. So, because you are. Like when I am testing, I'm part of this environment, I'm part of the whole system. So knowing that and knowing this thing that robot is not a human being, it's like a bunch of software, hardware components that are operated by a nice piece of code. But they have their behaviors which are sometimes unpredictable. And especially it can get even more unpredictable if you are like new to this, like me, if you don't know what you are doing. So safety first, like we have to be mindful when what we are doing with the robot, where we are standing, where the robot is going, because you never know. I mean, maybe some of you would ask, but don't you have some sort of safety functions? Of course we do. But somebody has to test safety too, right? Also, as a tester, I'm skeptical. So I just don't trust it ever. That's why I always have my shoes. Again, me showing on my laptop shoes and this vest. Even this vest will not save me from anything, but it's the regulator's rule. I mean, robot will not. There is no difference if I have the vest or not. Robot will just go away if nothing works. So ran over me. Yeah, it won't, but okay. Enough about safety. What I wanted to say about testing the real robot, dealing with the beast, and how we approach these testing sessions. Well, it's a bit complicated just because, as I mentioned, we only have like limited number of robots, and we have a lot of people, a lot of engineers among us who also want to do and have to do part of the work on the robot. So we consider in our company as robot time as something very special and expensive. So as testers, we have to be prepared for the testing session. Because I learned one thing ages ago from economics. That's the thing you heard probably about opportunity costs. And I see this a lot in testing. Opportunity cost is basically the price for the decision we are making right now. What do I mean by that? When I come to the test facility to work with my robot, if I have decided that now I will spend 2 hours preparing my testing charters, defining my goals, like requirements, risks, and do the planning now, I wasted 3 hours of special robot time. So I want to come prepared. Sometimes coming prepared means I have to take čistač grešaka with me. Joking, we don't need it for this kind of this robot, but sometimes it means I have to take pieces of the test equipment with me, some tools. I have to have my charters, documentation, some sort of, I wouldn't say like test strategy, but mission in place. What do I want to know more about this product after this testing session? So I would say preparation here is really the key, but also finding the balance, because I don't want to over prepare myself. I know this maybe sounds weird, but I just mean that we have to be ready for things that are not predictable, for unexpected situations, because we will discover, we will get new results from our first test sessions, and we need to adapt on the place and kind of change how we go, learn, and during the day, be able to adapt on whatever happens. And interesting thing happen, even when you are prepared, you did all of the homework, yes, I thought I will have the greatest day and everything will be really great. We will not find any criticalities, because we actually don't like to find bugs, because then we are not so happy. When there are really bad ones, we want to find harder bugs. But even when you're kind of by the book, the environment can basically trick you and surprise you. Because as I mentioned, these robots are operating within the warehouses. They have people around. We have different light conditions. We have even different air humidity during the day, during the year. And this all affects elements of the robot. It affects cameras, how cameras perform, how lasers are doing. Oh, sorry. So everything matters. And honestly, how to prepare for those things, I don't know. Some things you can kind of predict, but there were really situations we couldn't predict or we failed to predict. Let me share you one example or two. I'm not sure how we are with the time because my notes and... Okay. So let's see one example. So we worked hard. We finally deployed the fleet of 10 robots to the customer site, and everything worked fine for a couple of weeks. They did production, and we were satisfied with the result. But we noticed from the logs that one or two of our robots just stopped in the middle of one corridor, one specific place, and they couldn't get any new plans, so they weren't be able to move. And we, no logs, nothing useful. We figured that, what's wrong? We spent a lot of hours because we spent a lot of hours reproducing the issue at our own test facility, and we couldn't. So we kind of postponed the coming to the customer side and tried to let's see if we can recreate this issue at home, but we couldn't. Well, what happened? It turns out that customers, after we deployed everything, they changed the Wi-Fi network settings within the facility. Even we suspect that it's because of the Wi-Fi signals. Robots need Wi-Fi to be able to communicate. It's due to safety, actually, if somebody would be curious, because you always have to be able to remote stop it. So Wi-Fi is kind of needed thing for now for us. And we figured they changed something. They changed their network, and the robot was really that's a smaller version of robot, another type. It's 30 centimeters to the floor, and we totally missed it because when we were scanning the signal, you're walking with your device and you are in this height, but we should just and when we measured the Wi-Fi signal in this particular black hole, we call it the black hole, we immediately knew, that's the root cause. And we couldn't figure it out from, no log could tell us something useful. Only exploration and coming to the site and actually dealing with the real problem. Another one was with the light. That was interesting. So we were so happy. We did the best job. Our segmentation is the best in the world. Okay, of course, it's not the best in the world, but it's pretty good. We can recognize pallets, trailers, everything goes smoothly. Operations of loading, unloading are doing very well during the day until 6 p.m. What? Why 6 p.m.? And we noticed that it's not always exact, second. It changed a little bit over the days. Sunlight conditions. We had a window in our test facility, and at 6 p.m. there was a beautiful sunbeam that that aimed directly into our staging area, the place where the pallets are, and the robot took a scan. And the picture was too bright and it couldn't recognize anything. So, of course, when it came in the morning, everything worked, couldn't reproduce it. So, those are all of the unpredictabilities. Some you can predict, sometimes you just cannot. Because, slippery ramp or the floor will completely ruin your system because a robot will just slide through it. So. Yeah, having that said, there's one more thing that bothered me a lot, when it comes to robotics. What should we automate or what shouldn't we automate in whole of this mess of complexity? What's useful? What's maybe not useful? And I'm not saying that I answered the question, of course not, because that's another $1 billion question. But the good news is that some learnings I gathered from software, dealing with software almost the whole career, I could apply here. So what we did for start, because you have to start somewhere, first logical thing to automate is logs and a lot of data we are gathering from robots' behavior and all of the components. It's a pity to just waste this data. And of course, during the test session, you cannot observe everything. Like as testers, we are very observable, as one of my friends would like to say, but we cannot just observe every single problem, especially when you have a lot of movement, robot is driving, so you cannot see anything. So automating collecting this useful data and learning from it, it's quite a good thing to do. Another thing we figured that would be useful for us to automate is like simple smoke tests, like verifications if all of the components, because there is many of them, are up after changes within the system. Like, cool. Like it's useful for us. And the third thing is one of my favorite things is basically automating most essential use cases, but in a fashion that it also serves as a product documentation. Because what is best automation? It's the best product documentation. It tells you how the product actually works. So we find it we can consider that as like end-to-end testing maybe, but it's not like that because we don't vary a lot of things. We don't do a lot of variations. We are not there yet. So for now, it's like verification of if robot can complete like most essential use case, loading or unloading. What we still, like I'm not saying that these things we cannot do or you shouldn't or it's impossible to automate or not, I'm not saying that, but we don't have the resources or knowledge or skills or time, or we are just cautious. So things like safety, sensors, like physics, we are not dealing yet with all of those things. But I'm glad that we started doing something, even it looked, before I joined the company, it looked, oh, we will never build any useful tools we can use for automating pieces of our work. Like, we don't have skills. But hey, we just need time to learn them. So having that said, I'm really glad that we kind of dared to try new stuff, to build useful tools. I'm really glad that I kind of dared to try new industry, because even in the new industry, you can use some old tricks, but also build on top of them and learn new tricks, learn new tools, and like just try different testing approaches wherever I am. So having that said, that's it from me today. Thank you. And I hope you will have a nice keynote later.
Thank you, Irja. It was very interesting.
Thank you.
I have a lot of questions, but we don't have that much room for them. So
let's be quick.
Yes, let's be quick. Question and answers. If there is anyone who would like to raise a question here in the room. No. Do we have any?
Try.
Yeah. Yeah, I know. That's why we moved to Slido. So there is more. If there are extroverted types, so just shoot the question. For introverted, oh, really?
Oh.
What was the worst unpredictable behavior of a robot?
Luckily, we didn't have any injuries or stuff like that. Even, I will tell you, customers really like to just jump in front of it. Like guys in the suits, and they jump with their shiny shoes in front of the robot, so that's crazy. Unpredictable behaviors, most of the things were failures in this kind of situations. So I wouldn't say that we had, now I cannot remember some scary thing. Maybe when it went a little bit with the wheels, because physics and volume of the robot, it can happen that it can slip over the area which is like strictly forbidden, which it shouldn't like touch or smell with its wheels, but that can happen. So it always has to be, you have to be kind of mindful. Like also, I remember one time it got lost in the middle of the nowhere because of it couldn't localize itself within the space. So we hit the pallets with like full bottles of something and with our fork. So that's not good. We don't want to damage the goods, any goods, even if it's testing equipment. So that was pretty, I didn't like that.
Well,
I don't want them to behave like that.
There are more questions linked into that, to that. Just quick answer. Did you have to sign some potential death case documents caused by robot malfunction?
No.
Not yet.
No, without yet. No. Safety is something that you have to take seriously because nobody will even let you without some certifications and procedures. They will not let you in the warehouse or their facility. So, no.
More tech question. Do you use machine learning for object recognition in the warehouse?
Yeah.
How is it tested?
Oh. Well, that's another story. We don't do much like testing the models much earlier. So we basically test it on the real vehicle. The biggest problem is to get the equipment because, believe it or not, getting the exact types of the pellets that we are like currently testing, it's sometimes hard. There are many types you have in the world, and so we basically test it with a lot of guesses and successes, I would say.
And last question, do you think that testing bees in person motivates you to create tests with high quality?
Oh yeah, it motivates you to do best job ever. It's quite fun also, but it's also motivational.
Just a joke. I mean, we've heard it, adapt or die.
Yeah, definitely. Yeah. Or die.
Just back to Phil's talk today. Thank you, Irja, for a very thoughtful and inspirational talk.
Thank you.